That's a great question. I think a lot of folks ask that question. We're all very used to relational technology, right? Many of us as computer scientists, we've been steeped in this stuff all the way through professional careers, but also at university. And that model is based on a couple of very good branches of mathematics, predicate logic and set theory. And so those the challenges that those workloads that those databases are good for are where the mathematics fits, where you've got sets of things, and where those things start to break down is when you start to multiply those sets together. What's called joins in a relational database. And we know that in theory the relational model works, mathematics works, but in practice, as you do more joins in a relational database, things tend to slow down. That's because you're building up large sets of information, and then you have to filter towards the end to kind of get your answer. So it's to kind of make all the possible answers and then filter sort of model. And of course, when you've got large data sets, that can overwhelm computers quite easily. Yeah. Graphs are very different. They're not built on that branch of mathematics. We're built on graph theory, a very different part of mathematics. And in our world, in order to find informational goals, we navigate a network. We're not building up huge sets as we are in the relational world. We're kind of, I think of it rather childishly as a little robot running through a maze. And then the robot finds the ends of the maze. That's our answers. And in a modern computer, doing that, very efficient, because all we're doing is what's called dereferencing pointers. And turns out that's the one thing modern computers are really good at, the fetch execute cycle, where we dereference a pointer, fetch another address, dereference a pointer, fetch another address. And so by piggybacking on that, we can make graph databases very, very performant. We don't have accidental complexity that our traditional relational database brethren have done. And so we're able to tackle a different class of use cases very performantly in a way that the relational isn't. Yeah, I mean, whenever people ask me to talk about graphs, I get an involuntary smile. So I'm excited about so much in graph technology. Yeah, we hear graphs on my emblem bar at the moment. One of the things that I found profoundly exciting is the breadth of challenges that our users, our customers are doing. This morning we've had asset management in networks, we've had personal development and staffing, we've had all sorts of things, we've had fraud detection. And that's one thing that excites me, but actually, look, I'm a computer systems person. So I'm profoundly excited by software and systems. And one of the things that's delighted me in the last kind of couple of years in the graph space in particular is the emergence of graph data science. So we've had data science in IT for a while, but the emergence of graph data science as a distinct discipline where we take not only data points, but the connections between them. And we're able to run those graph algorithms that we all learned at university, the ones with funny Dutch names and so on, like Dijkstra. And we're able to run Google's PageRank algorithm and all this kind of stuff. But in the enterprise, you get great insight, not only from our data points, but from the topological context around those data points is profoundly exciting because it unearths things that are completely unobvious. Whether those are fraudsters in a transaction network or in the case I spoke to this morning, analysing the London Underground network and finding the seemingly innocuous station, Green Square, as the most critical station in the whole network. Those kind of things just don't happen without graphs. So with graphs and with graph data science, you get this explosion of insight into your data that I think it simply didn't exist before. I think that is profoundly exciting. Right, because let's get the bad stuff out of the way, the pitfalls. I've made them. Before I was on staff at Neo4j, I was a user of Neo4j, and I have made mistakes. So one of the mistakes I made, we were looking at corporate governance system. So the scandal at Enron was still in our minds at the time, if you remember. That was insider trading and collusion. And we were building a system that was designed to flag that kind of thing. So we had access to an email server, and we were looking for Alice emailed Bob, that kind of pattern. And of course in English, that sounds fine. We can without anyone raising any eyebrows, I can say, hey Amit, Alice emailed Bob, you know exactly what I meant. Yeah. But it turns out, when we were asked, well, what did Alice email Bob? We were stumped. We knew that there was some activity, but we didn't know what happened. And it turns out that English is quite imprecise as a language. So Alice emailed Bob is not at all what we do when we send an email. It's Alice sent the email to Bob, CC Charlie. So we'd missed out, because of the imprecision of English, we'd missed out an important entity in the graph, which was the email itself that they sent. Yeah. So we had to go back to the drawing board and we had to redesign our model so that we captured those entities. So that's the main, graphs are so easy. that sometimes when you look at a graph, you can read the sentence from the graph, Alice emailed Bob, and you think it's fine. So my main tip to graph modeling new people is to say, think about the entities, right? Don't miss out any entities by accident. But then once you're past that stage and you're implementing a graph, my advice to you again, for the new folks that might be watching, is having that you're not, this isn't relational. You don't have to build this in a top-down fashion. You don't have to know everything at first. You're not locked into a schema, which is terrifying and like handcuffs. You can evolve your model quite gracefully. So think about the first question you want to answer and build the model to answer that question. And then think about the next question you want to answer and evolve the model to answer that question. Now you can answer 2 questions and so on. This is a boil the ocean exercise as it is with relational. This is an iterative or agile exercise where you enrich your data model as you go along so that you can eventually answer all of the questions and more that you'd like to answer. So don't be worried. If you don't know all of the design up front, it will come as you iterate through, and that graphs are very amenable to that kind of delivery mechanism. I'll go back slightly in history. So 2021, graphs I think have broken through at that point. Neo4j raised the largest financing round in database history, not graph database history, but database history. So we raised like a $450 million round. I think at that point, that's the market saying, we have faith in this category, and we have faith in this particular company in the category. I mean, actually, I'm rather more happy that there's faith in the category. Neo4j is a great company. We're definitely going places. But what it told the market was this technology exists. It's not a weird niche thing as it was 10 years ago. It's a mainstay of what enterprises are going to be using for the next 10, 20, 30 years. So that's really important. From there, we've observed growth both in the category and our own metrics internally, showing that graphs absolutely outstrip the growth of all other data categories. In fact, we've observed that all the way back a decade ago, 2013 onwards. Graphs have by far outstripped growth of all other data tech, which I think sends again another stronger signal to the market. Graphs are being used, and it's not just being used in, back in the day as it was telecoms, networks, and social computing. It's being used in a breadth of things. So I think, one thing would be the metrics around category growth and, Neo4j revenue or number of employees or so on, But I think what's more interesting is the number of use cases in which we're now seeing graph. And when I started my journey in graph, I did product catalog, retail recommendations, social, and telecoms. Kind of 4 use cases. I don't have enough fingers anymore, or toes, to count the number of use cases we see for graph. And because graph is becoming the general purpose database for the next decades, as relational has been for the previous decades. It's a very horizontal thing. We're able to tackle a bunch of use cases which are both emerging and traditional, and execute them with aplomb and dignity. In terms of metrics, Neo4j's growth has been, rapid. I joined, I think I was employee number 6 or 7. I was the first foreign guy that we recruited because we started the business in Sweden. Of course, I told my Swedish colleagues, I'm British, I can't be foreign. You're Swedish, ergo you are foreign. British humor does not travel well, by the way. But now we're just shy of 1,000 employees globally, good footprint here on the subcontinent, and in fact, Asia Pac as a whole is Neo4j's fastest growing region. So we are accelerating our presence here, both on the technology side, with technology specialists in the country, and on the commercial side, because we have the customers both for the traditional kind of outsourcing market, the tech giants that are based here, but more increasingly for folks that are looking to serve the domestic market. And this is a mixture of established businesses, but also we find startups that are young, hungry, and they're not looking to the tiny markets of Europe for their success. They're looking to the billion people here on the subcontinent for their success. So there's a really interesting shift that we're also seeing these young businesses of educated, passionate young people building their future on top of the graph as well. Presently, India is relatively small. We only really moved into APAC 3 or 4 years ago. We were a European business, which is kind of, with no disrespect to my European peers, it's kind of, it's the old world, right? So it's stable, it's mature, it's fine. And as a tech business, our next geography had to be the US, because that Silicon Valley is the epicenter of our business still. But having moved into Asia Pacific 4 years ago, it's very clear, like with the population growth here, with the capability and technology here, with the community here, it's a big growth engine for us. India is a strategic investment. As I mentioned, we're great technology specialists here, not just the commercial org. And in fact, some of the people who don't actually know much about Neo4j and our backstory is that Neo4j, in its very humblest beginnings, was a collaboration between the Neo4j team, my boss actually, the CEO of Neo4j, and the folks at IITB here in Mumbai. So we actually owe an awful lot of our, if we have success, our modest success, an awful lot of that comes from collaboration with the Indian academic community at IITB. And as someone, I lead research at Neo4j, I know that in my medium-term future, we will be opening up collaborations with the Indian academic community and taking some of their database and systems research and being able to incorporate that into the product technology roadmap of Neo4j Listen Check.
For more updates from CXO TV, please like and subscribe to our channel.